Section 1.3 covers subsets. So let's start with the definition. Suppose you have two sets, A and B. If every element of A is also an element of B, then we say that A is a subset of B. And we denote this with this subset notation. So let's add a little note here. You have to be careful with this notation. So some books use the subset without the little equal sign under it instead. And we'll talk a little bit about those different notations and sort of the different uses of them in a minute. So what does it mean that A is a subset of B? It means that every element of A is also an element of B. So let's maybe think about an example, and then we'll go back to the rest of that definition. So I could have A is equal to 1, 2. And then let's think about what B can be equal to. I need every single element of A to also be an element of B. So B must have all of those same elements, but B is allowed to have extra elements as well. Right, so in this case, A is a subset of B since each element, just 1 and 2, of A is also in B. Okay, we say that A is not a subset of B if that's not true. And in case we write the same notation with a kind of a cross through it. So A is not a subset of B. Okay, so what is true if A is not a subset of B? So I want you to take a second and think about that. What is true if A is not a subset of B? If you need a little more time to think, you can go ahead and pause the video, but I'll go ahead and fill in the answer here. So if A is not a subset of B, there is some element in A which is not in B. Okay, so how did I get that? Well, it was not true that every element of A was in B. So there had to be at least one element in A which was not in B. So maybe if A was equal to 1, 2 again, and B was equal to, let's say it has 1 in it, then it can't have 2, but maybe it has 3 and 5. Then A is not a subset of B. All right, so let's do the little notation discussion here, just to make sure we have all of the pieces together. So we use this symbol generally to be subset where it's possible that they could be equal. If I want to say that it's a subset where they're definitely not equal, I can use this notation for subset not equal. But usually what people use is this middle notation for subset not equal. It's kind of like when you have a less than versus a less than or equal to sign. So I can say 5 is less than or equal to 5, but I can't say 5 is strictly less than 5, but I could say 5 is less than 6. So you're allowed to use the equals when it's possibly equal, or not, and then you can only use the strict one when it's definitely less. We just have to be careful about this middle one because it's not true in all books, although it's pretty true most of the time. So I like to use this symbol and this symbol so it's extra clear. Okay, moving on here. So here's some questions I want you to think about, and we'll talk about these together. So what is true if A is a subset of B and B is a subset of A? So I want you to kind of think about this a little bit and see what things you can say are true, if that's true. And then the second question I want you to think about is what sets is the empty set a subset of? So can you think of a set that has the empty set as its subset? Or what would it mean to have your empty set as a subset? So think about those questions and we'll discuss them together. All right, let's go ahead and actually come up with some subsets. So what are the subsets of the set B that has A, 1, and star in it? So I want to think about, okay, what are the different elements that I can have in that subset? Well, I can have A in my subset. So maybe we can start listing them out. I can have a set that only has A in it. I could have A and 1. I could have A and star. Or I could have A and 1 and star. So I think those are all of the different ways that I can have A in my set. I could also not have A in my set. So maybe we just have 1, we just have star, or we could have 1 and star. And then I could also just have the empty set. Right? Everything in the empty set is also in my set B. So it does satisfy the subset relationship. And then I think those will be all of my sets. So we say, okay, what are some ways we could have come up with this? How can we think about it? What I noticed is I had to decide, is A in my set or is it not? So I start with my first element, A, and I ask myself, is it in the set or not? So if it is in the set or not, we're going to end up in two different categories. So then I'm going to go to 1, and I'm going to ask myself, is 1 in the set? Yes or no. And down here for 1, it can either be in the set or not. And then finally, for the last element, star, we'll ask ourselves, is star in the set? And if we say yes, we'll put it in the set. And if we say no, we won't. So yes, no, yes, no, yes, no. Okay, so what do I do with all of this? What I'm going to do is I'm going to follow along each of these paths to the end and then just put those things in the set depending on what the rules tell me, right? So I say yes for A, yes for 1, yes for star. That gives me the A1 star set. The next one down, I say yes to A, yes to star, or sorry, yes to 1, and no for star. So I got an A and I got a 1, but I didn't put the star in there. Then maybe we go down one more. We'll do this path next. So we said yes for A, we said no for 1, and then we said yes for star. So I can follow each of those paths along, and each of them will lead me to a different subset. So I'm going to go ahead and give you a second to fill those in. You can write out what different subsets you get. I'll do the same so we can compare. So compare what you get, what I get. If you need to pause me for a second, you can. But you should see that the subsets we get here are the same as the ones we had drawn out originally. Okay, so the quick thing I want you to think about is sort of thinking about this method it should help us have an idea of how to determine the number of elements in a set. So if I have a basic set A that has n elements, how many subsets does A have? So we saw that for magnitude of B equals 3, we got 8 subsets. So for general n, how many subsets do you have, and can you prove that? So that's what I'd like you to think about. Okay, finally, I want to give you some time to kind of look over some examples to really practice exploring this element and subset notation. So let's pick a few of these to really go ahead and talk about. Okay, so I've highlighted a couple of them. So let's go through and talk about those. So the first one, I have this set, and the elements of this set are 1 and the set containing 1. So we can think about this as having some sort of set or a box, and the elements are 1, and then the set containing 1, which I can think of as a 1 inside of a box. So this question says 1 is an element of the set that has 1 and the set containing 1. So 1 is one of the elements, so that's why I can say that. For the next one, it's asking us if 1 is a subset of this set. But you can only be a subset, if you're a set. So 1 can't be a subset of the set containing 1 and the set containing 1 because it's not a set itself. So then we would say that it's not a subset. Okay, let's look at some other ones down here. I encourage you to read through the rest of these. These are all from the textbook. Let's look at number 8. The set of natural numbers is a subset of the set of natural numbers. Any set is always a subset of itself because every element in the natural numbers is in the natural numbers. It's easy to think about. So therefore, we know that it's a subset. The second one is talking about elements. Remember, the elements of the natural numbers are things like 1, 2, 3, 4, and so forth. None of those is the empty set. Therefore, the empty set is not a subset. Sorry, it's not an element of the natural numbers. However, the empty set is a subset of the natural numbers because the empty set is a subset of every set because every element in the empty set, well, there's none of them, is in the natural numbers. Okay, let's go down and think more about this empty set in natural numbers. Now I have this new set. It's the set, and the element in that set is the natural numbers. So here there's only one element, and that element is the natural numbers. So the empty set can't be an element of that because it's not the natural numbers, and the only element is the natural numbers. Now, the empty set is a subset of the set containing the natural numbers because it's a subset of every set. Okay, finally, we're going to think about the set containing this empty set and ask ourselves if it's an element of the set that has the empty set as its first element and the set containing the natural numbers as its second element. All right, so that set containing the natural numbers is hanging out right there as one of the elements. I've literally listed it as one of the elements, and therefore it is an element. So I encourage you to take some time, read over the rest of these, make sure they make sense, and you can ask any questions you have about them in class.